Let's look at the work done by a spring. Suppose I tell you that I have a force of 750 pounds compresses a spring 3 inches from its natural length of 15 inches. So this is where it wants to be. There is no force being applied to a spring when it's at its natural length. Find the work in compressing the spring an additional 3 inches. Now, you remember Hooke's law says that the work done, the force, is equal to kx. Now, I told you we're usually going to have to find k. In this case, you were told that it took a force of 750 pounds to compress 3 inches. So k is F divided by x, and this is really a delta x. So, because this is a compression, so the force is 750 divided by 3, so k is 250. So I know for this spring, the force is equal to 250 times x. Now, what is the incremental work? Let me change my pen color here. What is the incremental work done? The incremental work done is the force times the distance. All right, now the force is 250 x times delta x. Now, we want, in this case, we want to find the work done in compressing it if it's from 3 inches, an additional 3 inches, so that's 6 inches. So the work done is going to be from the initial compression to the final compression, f of x dx. So this is going to be from 3 to 6, because this is where we started. We compressed it to 3, and then we compressed it 3 more. F is 250 x dx. And so this is 250 x squared over 2, evaluated at 3 and 6. So this is 125 times 6 squared minus 3 squared, or 3,375 inch-pounds. So the tricky part for these problems, 1, you have to find k. 2, you need to rewrite Hooke's law. And then 3, you write your incremental work. 4, you need to find the limits of integration. Are you going from the relaxed state to a compressed state, from a compressed state to a more compressed state? So that's where you need to find your limits of integration. And then the last, of course, is simply doing the integration